Okay, so we skipped over part 3 because the software that needs to be used doesn't work on our systems here. So we're just not going to do that. Instead, we're going to move on to part 4, which is mega droughts and the people of Pueblo Bonito. That looks like a huge dust storm. So in the 1930s, the Great Plains region of the United States was devastated by drought. The 150,000 square foot mile area encompassing the Oklahoma and Texas panhandles and neighboring sections of Kansas, Colorado, and New Mexico had little rainfall for several years. The combination of poor land use practices, such as destructive plowing, light soil, and high winds formed a destructive combination. When the drought stuck in the mid-1930s, the soil lacked the stronger root system of grasses as an anchor, so the winds easily picked up the loose topsoil and swirled it into dense dust clouds called black blizzards. The region became known as a Dust Bowl. Recurrent dust storms wreaked havoc, choking cattle and pasturelands and driving 60% of the population from the region. Although the drought in the 1930s was significant, one paleoclimatologist have identified periods in our history when droughts in a region have spread over a decade or more instead of a few years. These extreme weather environments are termed megadroughts. In this part of the lab, you will investigate a long-term data set produced by tree ring records as a proxy to identify the existence of drought and megadroughts that may be affected the people of Pueblo Bonito and the surrounding region. So we're going to learn about megadroughts in the past and future. Download and read the one-page article, Water Resources, about megadroughts by Dr. Ed Cook. Cook's article is found on the right side of the document. So if you download the article, it looks like this. It's called Water Resources, How Severe Will Freshwater Resource Shortages Be on a Regional Scale? So over here we have, it's by Richard Harding. And it says that Cook is going to be on the right side here. So I believe we have two separate articles. So you are just reading this portion over here. Let's see if I can make that a little bit bigger. Climate model projections of future hydroclimatic change associated with increasing atmospheric greenhouse gas concentrations are sobering and, depending on where you live, very alarming. For example, southwestern North America is projected to enter into a long-term drying trend in the subtropics and mid-late to mid-latitudes. And this trend is increasing. Aridity may have already begun. Thus, the unprecedented 2011 Texan drought is an example of what might happen with increasing frequency and duration in the future. Independent of whether or not model projected radioactivity, forced drying is actually happening now. There is abundant paleoclimate evidence for the occurrence of past megadroughts in North America, and they do give citations for all that. I'm not going to read all the citations. This also happened in Asia and Europe that dwarf any periods of drought seen in instrumental climate records over the past century. The seminal property of megadroughts that differentiates them from even the most severe droughts observed today is duration, with the former often lasting several decades to a century or more compared to just a few years to a decade or so from the latter. Figure 1 shows 3 such megadroughts reconstructed from tree rings that hit the Mississippi Valley and the United States during the early, middle, and late medieval times. These megadroughts lasted 46, 148, and 61 years respectively and are ominously located in the American breadbasket, where similar droughts in the future would have catastrophic consequences on agricultural production. This also means that water resources, planning, and infrastructure design based on observed hydroclimatic data are unlikely to be resilient enough to handle the possible return of megadroughts that we now know have happened in the past. The cause of past megadroughts is still not fully understood, but persistent patterns of cold La Nina-like sea surface temperatures in eastern equatorial Pacific ENSO region have been strongly implicated in North America, along with the possible influence of the Atlantic Ocean there as well. Perhaps more importantly, the paleoclimate record indicates that megadroughts occurred more often during an earlier period of generally above average temperatures called the medieval warm period, approximately 700 to 1,200 years ago. It is not important to know whether or not the MWP was as warm as today. Rather, the paleoclimate record of the past megadroughts simply tells us they are a natural part of the climate system with no need for anthropogenic greenhouse gas forcing to ignite and sustain them. And two, rather ominously, they appear to like warmer climates, such as what occurred during the MWP. Given the climate model projections of future drying and the high likelihood that global warming will continue throughout the 21st century, we may therefore be entering into a new era of megadroughts with potentially catastrophic consequences to water supplies needed for human consumption, agriculture, energy production, and for maintaining the aquatic environment. The degree to which any future megadroughts caused by human-induced global warming will resemble those in the past is unclear because the climate-forcing operations today are different from the past. Regardless, the stage appears to be set now for some possible radical future changes in hydroclimatic variability, if the past is any guide. So here we can see what they're talking about was as far as droughts go. It all happened right in this area here, which is where there's very little rainfall. So going back, we should now be able to answer 4 questions. So number 1, how do mega droughts in the past compare to those that have occurred in the past 100 years? The mega droughts in the past have been much more severe and longer lasting. They've lasted over decades or even over a century. Remember I told you those 3 numbers? It was like 48, 100 and something, and then 60 something. And those were all the amount of time that droughts lasted. What is one possible cause of mega droughts in the past? The persistent patterns of cold La Nina-like sea surface temperatures in the eastern Pacific might have caused several of the megadroughts. Number 3, what factors are increasing the probability of catastrophic megadroughts in the future? The increasing global temperatures due to the increased carbon dioxide emissions into our atmosphere may contribute to future megadroughts. And number 4, based on the graphical data given in the article, did your state or your community experience a severe drought in any of the 3 periods shown? So if we're looking, so we're up here in Pennsylvania, we're in the blue. So we didn't experience mega drought, but we did have some in that very last drought that they had. So just a little bit in the very last one. Investigate the long-term tree ring data. The time series graph below shows a very long tree ring chronology developed by Dr. Henry Racino Mayer and others from an amazing site called El Mathis located in New Mexico. At this site, trees are growing on an ancient lava flow. Because the lava holds so little water, the tree grows very slowly, and their annual rings are sensitive to changes in the amount of summer precipitation. In this harsh environment, dead trees can resist decay for a long time. So if a tree dies and falls over, it may not rot for hundreds or even thousands of years. Draw up into Alma Pace and take a look around the ancient lava beds and look for dead trees as well as living ones. Scientists can collect samples from both living and dead trees at sites like El Malpais, and there is enough overflow between the 2 tree ring records to confirm the dating of the dead trees about 100 years. Then they can combine the data to provide a continuous record of changes in precipitation marked by varying tree ring growth over the past 2,000 years. The data from El Malpais site was also used to confirm the dates of many ancestral pueblos in New Mexico. The vertical axis, which is the y-axis, of the time series graph below is precipitation in a given year in millimeters. So we're talking about during the cool season from November to May. Oh boy. So we're on a lava flow here. And you can see the ground a little bit. It's glowing in different places. So it looks like we have a live tree right here. That one looks like it's dead. And they just kind of hang there. That's definitely a dead tree. It's pretty interesting if you notice how they're growing as well. It's kind of in a curled manner instead of straight up like this one. So you can kind of determine live or dead. This is obviously a dead tree that has cracked. Use the sliders at the bottom of the page to interact and explore periods of time with scant rainfall. Are there any mega droughts that last 10 to 20 years or more? And we'll answer the rest of the questions with this little bit. So that's number 5. After studying the 360 image of the LMIPACE site, what factors have made this an exemplary site for tree ring research? So they're talking about these pictures here. So it's really great to have tree ring research done where there is a very harsh environment, which is what we have here. We know that the trees are going to grow really slow. They're on a lava flow, so there's not a lot of soil. There's not a lot of rainfall. They're going to be very sensitive to moisture changes. The trees kind of look a little stunted because they grow so slowly. If we go back to number 6, list any periods of megadrought you can locate over the past 1,000 years. So that's going to be using this little guy up here. So we're looking from this period and up. So let's go to here. Stretch it out a little bit. So we have tree ring precipitation reconstruction. That's going to be the yellow. 10-year average is the blue line, which is a little bit smaller in here. Green is historical November to May precipitation values, and purple, which just goes straight across, is the long-term average. So this is going to show all periods that had a severe drought from 1660 AD until 2004. The thing to notice about this graph is that it shows summer precipitation from tree rings, cool season precipitation, which is a dashed line, and periods when the drought was reconstructed for both summer and the cool season, which is a black shaded area. And this is what authors would refer to as a perfect drought. The 2 most severe and sustained cool season droughts are estimated to have occurred in the mid-8th and late 16th centuries. So you can actually stretch this out even more if you want to. So let me put 1,000 down there, and we'll put 2,000 up here at the top. All right, so it looks like tree ring reconstruction was extremely low sometime around here. So also low here, and it was low down here. Cool season reconstruction is going to indicate that 3 of the most severe and sustained droughts in the past 2 millennia occurred in the past 120 years. And these 3 events would have occurred from 1891 to 1907. So we're looking for 1891. So you can see rainfall is really going downhill here to about 1907. So I can pull this in here. So look at how low these numbers were down here. So that's what we're talking about when we say there is a drought. And then you can see there's a spike in the amount of rainfall that happens. So we got out of that drought there. We also want to look at 1944. So it dipped down again right here. And you can see it continuing to go down, 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 down. Until somewhere, let's see, it pops up a little bit right here before going back down again. So to about 98 or so. And the last one. Looks like this was kind of a low point here, somewhere around 96. And it stayed low until, oh gosh, 2002 was our last one. Okay. And number 7, how would drought impact you? Think about and list how a 1 or 2 year drought might impact your life. Now compare this to how a 10-year drought might impact your life. How would you respond to these types of droughts, and how might they affect you and your family? So this isn't something that you need to look up. This is you personally. Tell me, what do you think? A 1 or 2 year drought, it might limit how often you wash your car, or maybe you wouldn't be watering your lawn. It might increase the risk of fires in some areas. But a 1 or 2 year drought would not really impact you that significantly. You would still have water to do all the basic things you need to do. Now, a 5 to 10 year drought, you would have the same restrictions as that 1 or 2 year drought. However, if we don't have water to water crops, we're not going to have any food. It might drive prices way up. Things are going to be picked over in stores, and there's going to be a lot more fires. How often do extreme 1 to 2 year droughts happen roughly? How about mega droughts? How often do they happen? So an extended drought, they happen in every century and sometimes several times a century. These events vary in severity and length of each event. So normally over in California, we have all those wildflowers that happens almost every year. That would be kind of a shortened version of an extreme drought. Question number 9. Scientists estimate that the ancestral Pueblo people left Pueblo Bonito around in the late 13th century. Based on the data that you measured from the Almay País data plot, could a severe drought be the primary cause of their abandonment of the village? I would tend to believe that yes, absolutely, they left because they didn't have any water. These people didn't have an irrigation system. So if there's no water around, they have to leave. They got to go where the water is. It's the same with, you may have heard of different Native American tribes traveling with the herd of the buffalo. They had to go where the food went. Number 10, take a look at the most recent decades in the Almay País plot. Based on the data, is this region of New Mexico in a period of drought, or for the past few decades, have they been average? So looking at that, it's kind of dipped down some, so I would definitely say that it's been below average. Number 11, given what you have learned about drought through time based on tree rings, would it change your mind about living in that region? What about farming in that region? If you were a water manager for New Mexico or for Chaco Canyon, Pueblo Bonito, and the Almay País data are located, how would this affect your thinking about managing water? There's a few different things you could say here, but ultimately I believe that it would be very difficult in managing that resource, because it's not like if you run out of water, you can just go grab more. If there is a mega drought in that region, you need to be prepared for it or have some type of a plan in place, because we know that they are going to occur again. All right, that is it for our last section of this lab, and we only have 2 more labs to go.